Welcome to lesson 2.3.2, Analyzing Asymptotes and Transforming Rational Functions. So what I've given you is a couple of pages or a few pages out of your textbook, and you should open that so we can be looking at the same thing, and also a Google Doc where you can type in your work and type in your answers. So you'll recall that if we have a degree 3 polynomial, we should have 3 zeros. Degree 4 polynomial has 4 zeros, and so on. So in rational functions, the polynomial that's in the denominator of the function will determine where vertical asymptotes will be located. Now, just because it's a degree 2 does not mean there's automatically 2 vertical asymptotes, but there could be up to 2 vertical asymptotes. And we're going to see in a later lesson why that is. But in this lesson, we're just going to focus on looking for zeros in a denominator. So the first question you're asked is, Sarah, determine the vertical asymptotes for the function f of x equals 1 divided by 2x squared minus 14x minus 16. And then Sarah says the terms in the denominator have a common factor of 2, so she factored out the 2, and then she factored the quadratic. We'll use the box method today. She probably used reverse FOIL or box method. And so she ended up with the binomials x minus 8 and x plus 1. It does appear she did that correctly, but we'll check. And then also she set each of her factors equal to 0, but not the 2, because 2 is just a constant. But she set her x minus 8 equal to 0 and solved that. And she got x equals 8 and x equals negative 1. And she says there's vertical asymptotes at those two numbers, at x equals 8 and x equals negative 1. Is she correct? Well, she actually is correct. The zeros of this polynomial, let's see if I can move this so you can see all of it. The zeros of this polynomial are the x values that cannot be included in the domain of the function. So what I've done to show it to you so you can visually see this is I've gone to Desmos and I put in the function that we're given here. And I put in the original function, not her factored form. And you'll notice that there's a vertical asymptote at negative 1 because this graph is not touching negative 1. You can use your cursor to kind of go along this graph. And you'll see the y values just keep getting bigger and bigger, closer to negative 1, but they just won't reach it. And over here's the same, so it won't reach negative 1. And then the same happens at 8. See, there's a vertical asymptote here, 7.991, but it's not going to reach it. It looks like it touches, but it doesn't. And the same over here. So there are vertical asymptotes in the graph at those two locations. All right, the next thing we're asked to do in your handout, if you'll turn to the next page, is to analyze these rational functions. And so we have 7 of them to analyze. And for each one, what we're going to do is actually use algebra and not use the graphing calculator, at least not right away, to analyze the denominators. So what we're looking for are where the denominators are equal to 0, or what value of x will give you a denominator of 0. So for the first one, it's pretty straightforward. You have 7x minus 35. So what we could do is just set 7x minus 35 equal to 0 and solve that equation and get x equals 5. So there's a vertical asymptote at x equals 5. The second one, since it's already factored out, is pretty easy as well. Set each factor equal to 0. The first one is just x, so that vertical asymptote would be x is equal to 0. The second factor was x minus 2, so of course you add 2 and you get x equals 2. The third one, I did work that one out. 2x plus 3 is equal to 0, so you would subtract your 3 and divide by your 2. So your vertical asymptote would be x equals negative 3 over 2. So those are pretty straightforward. You can verify all of those by graphing in the graphing calculator, and it does tell us to do that. So I'll leave that for you guys. All right, the next ones, we don't have our denominators factored. So what we're going to do is I put a box in here for you, and I got you started. I put the x squared term in one corner and the negative 10 in another corner, opposite that. And if you multiply those two terms together, you get negative 10x squared. So the x the x's that go in the two remaining corners of this box have to have a product of negative 10x squared, and they must have a sum of negative 3. So the only two that would do that would be negative 5x and positive 2x. Those have a product of negative 10x squared, and they still have the sum negative 3x, which is what we want because of the negative 3x in the middle of that polynomial. Now we're going to put our factors on the sides, so I hope I set this up right. This will be an x because the two terms on the bottom row have a common factor of x. And on the top row, these two terms have a common factor of 5. You will take out a negative 5 because the first one was negative. And then underneath here, the two in the left column have a common factor of x. The two in the right column have a common factor of 2. And you should notice that your product, if you multiply this back out, does work. If you have x times x, that's x squared. 2 times x is 2x. Negative 5 times x is negative 5x, and negative 5 times 2 is negative 10. So that does work. So what we'll do now is we'll set each factor equal to 0 and solve. So one of your vertical asymptotes, and I'm going to use my equation editor here. So let's use that and say x equals 5 for one of my x-intercepts. X minus 5 will give me an asymptote of x equals 5. And then x equals negative 2 will be, let me put a space in there. And I think I'll make this red or something. So let's go back out here and change this to red. All right. So there we have it. X equals positive 5 and x equals negative 2. All right, so you may want to pause the video and try this next one by yourself, but I'm just going to keep going. So if you don't pause it, you're going to know the answer before you get a chance to try yourself. We're going to multiply together the 2x squared and the 4. There was no common factor here. That is the first step, but they haven't given us one with a common factor yet. So what can I multiply to get 8x squared? That adds up to positive 9x. Well, let's see, 8 plus 1 is 9, so I could use 8x in one of these. Let's do 8x and 1x in the other. So 8x and 1x. And now that I've done my two x's, and they do have the correct sum and product, I'm going to put my common factors. The left column, those two have a common factor of x. The right column have a common factor of 4. The bottom row has a common factor of 2x. And the top row has a common factor of 1. So my two factors are 2x plus 1 and x plus 4. So set each one equal to 0. 2x plus 1 equals 0. 2x equals negative 1. X equals negative 1/2. And I'm not using the editor. It's not very pretty, but I'll just leave it. All right, this, I'm going to bold that and red it so we can see it good. All right, the other one is x is equal to 4. That one's so easy. I'm just going to put x is equal to negative 4, or x plus 4 equals 0. So x would equal negative 4 would be my vertical asymptote. All right, and all of these problems we will type in the calculator. I'm not going to show you that here, but I will show you that on the next couple because we're going to graph those in the calculator and see what's going on. The next one says analyze each rational function. Where are the vertical asymptotes? Well, this first one, the denominator can be factored, and it's basically easy to factor with the difference of squares. So I'm going to use the equation editor this time to make it prettier. So I have x squared plus 1 and x squared, by the way, shift 6 is an exponent in case you didn't know, minus 1. All right, so that would be difference of squares, but I have another difference of squares, x squared minus 1. So let's take each of those. Let's leave the first one there. So I'm going to do new equation, and then I'm going to do, well, hello. It's not working. New equation. All right, so x squared plus 1 whoops, go right first, plus 1. And then we need x plus 1, x minus 1 for these two factors. So what I have here, and I'm going to make this red so it sticks out a little better. So what we have here for this one is, you'll notice I have an x plus 1, so x equals negative 1 would be a vertical asymptote, and x minus 1, so x equals positive 1 is a vertical asymptote. But x squared plus 1, you can't get a real number for x there. If you were to solve that, x squared plus 1 equals 0, you're going to get imaginary numbers. These are not going to be on the axis. I mean, these are not going to be values that we can plot on the graph. So we really only have 2 vertical asymptotes here. So let me start a new equation. X equals negative 1 is one of our equations. Move that over. And x equals 1. So we only have 2 vertical asymptotes. What I want to do here is actually graph this one. It's 7 divided by x squared minus 1. So let's go back to Desmos. And let's put that one in. So we have x to the 4th minus 1. I think it's right. Let's double check, make sure I copied that right. Yeah, x to the 4th minus 1. All right, so here is my graph. So notice at negative 1, I might have to zoom out a little bit or zoom in. Can't see it too good. Let me zoom back in. At negative 1, this is not touching. You see this branch is going up, 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 up. It's getting real close to negative 1, but it's not reaching it. And then down here we have the same thing happening. And then there's another one at positive 1. It doesn't touch the positive 1 on either side. If you go to the table, let's create a table to see more. Move this over. If you do plus, you can make a table, and you can put in the value negative 2, and then you can put, I guess, f of x, f of negative 2. Will it let me do that? Yeah. So that works, but let's do negative 1. I'm going to do f of negative 1. And you're not getting any point on the graph. It's not showing you that value. It's not there. All right, so we can actually see 2 vertical asymptotes here. You're not seeing more than that because of the x squared. And notice how this doesn't touch the x-axis. You know, you don't have the roots. You know, it's sort of like that. All right, so the next one says, let me bold that. Make that pretty too. All right, so the next one has x squared plus 2 in the denominator. Well, this time you can't really solve that. X squared plus 2 equals 0 is going to give you imaginary solutions. So let's put it in the graph and see what it looks like. We have 2 on the top and x squared plus 2 on the bottom. So let me go back and do that. 2 on the top and x squared plus 2 on the bottom. All right, so this is different. I'm going to zoom in a little bit so we can see better. So this function is you can evaluate it at negative 2, negative 1, 0, 1, 2. You can plug in all those numbers if you want, and it looks fine. There are no vertical asymptotes, and that's because this denominator will never equal 0. So in this case, that's all you have to put for part B, is there are no vertical asymptotes. So I'm going to come up here, and I'm going to go over here. All right, now this last one is pretty obvious. It looks like there's a vertical asymptote at x equals negative 2 and x equals positive 5, but you know, looks are deceiving. So we're going to put this one in the calculator and look at it because it's a little different. And even ask in the directions, what's so special about g? So we're going to put x plus 2 in the numerator. So go back to your calculator and put an x plus 2 out on the top. And on the bottom, we're putting the x minus 5. So x plus 2 and x minus 5, I think. Wait a minute. Did I see that right? Yeah, x plus 2 and x minus 5. All right, x plus 2 and x minus 5. All right, so it looks like the graph is doing okay. I'm not seeing much of it, so we'll need to drag it. You can actually zoom out and see a little bit more. So it appears that at 5, so let me go to the table and put a 5 in here and see what that is. F of 5. Yeah, we're not seeing any point at 5 because there's a vertical asymptote there. But you know, at negative 2, if you click on negative 2, it's going to say undefined. That's because you can't, you can't plug a negative 2 in this denominator. But there is an x plus 2 on the top, so that's kind of interesting. So the graph does not have a vertical asymptote at negative 2, but basically what happens at negative 2 is there's a hole in the graph. You cannot see it. You know what? This is one advantage of the TI-84 Plus calculators, because you can actually see a hole in the graph in the TI-84 calculator. So we'll talk about that in a future lesson. But the answer to G is your vertical asymptote will be x equals 5 only. It will not have one at x equals negative 2. So let's put that. And let me go back and make this pretty. All right, the next one is whatever floats your asymptote. All right, Abby and Natasha disagree about this function. P of x is equal to a divided by x, where a is constant. Abby says the horizontal asymptote will vary depending on what value a is. And then Natasha says all rational functions of this form will have a horizontal asymptote and y is equal to 0. Who is correct? And explain your reasoning. Well, actually, Natasha's correct. If you have a function y equals a over x, a is some number over the variable x, no matter what you put it up there for the a, it could be a positive number, a negative number, it could be a big number or a small number. It's not really going to matter because the larger x becomes, the farther, the closer this graph is going to get to 0. So here's your answer. The end behavior of the function determines the horizontal asymptote in the graph. The end behavior is when values of x become very, very large or very, very small. When x is large or small, think of positive million, positive 100 million, negative 100 million. The value of y will get close to 0 no matter what value is chosen for a. And finally, it says in number 2, our last part is to determine a rational function with given characteristics. Vertical asymptotes, x equals 3, x equals negative 1, x equals 0. So in this case, we're just going to type in, and I didn't really separate these, so you'll have to type it down here at the bottom. Let me fix this. I've got huge font here. So what we're going to do is type in a function. I'm going to use the equation editor and type y equals, and you will need a fraction, so click on the fraction. Let's see if I can find it. Here it is. And you can put whatever you want on the top. I'm just going to put a 2 there. You could put a 1 up there. I wouldn't put an x up there unless you, not on this one for sure. And so now we want to have a vertical asymptote at x equals 3, so that means one of my factors needs to be x, x minus 3, because that'll give me a 0 in the denominator at 3. The next one is negative 1, so let's do x plus 1. And then finally, let's see, I want a 0, so I just need an x. So you can put it here, or you can put it at the beginning. I'm going to blow this up because this is tiny. Let's make this really big. And let's make this, I don't know, how about red? Okay, so this will be A. All right, so the next one, and of course you can type all these in your graphing calculator to verify that they are coming out like you want. The next one says we want a vertical asymptote at x equals -7 and x equals 12. So I'm going to copy this one. I'm going to paste it. I'm going to change this to B. Now let's see, I want a -7 and a +12. Well, -7 means I need x plus 7. And +12 means I need x minus 12. And I do not need this x here because that would be a 0. So the second one is that. And you'll notice I'm using y equals. You could do f of x equals, g of x equals, whatever. All right, the third one says no vertical asymptotes. Well, if that's true, then that means the denominator can never equal 0. So one good way to make the denominator never equal 0 is to put an x squared down there with something added to it. Now, if you just make it x squared, it's going to have one at 0, so you can't do that. You got to add something to it. The sum of two squares is not factorable, so that would not have a vertical asymptote. So I'll just leave it x squared plus 4. You could put x squared plus 2 or 1 or anything really, but don't put x squared minus something because you would have the difference of squares. Even if the number was not a square, it would have an asymptote at that square root. So you don't want to put a minus sign. All right, the third one, a vertical asymptote at x is equal to 5 and a horizontal asymptote at y is equal to 0. Well, let's see. You might want to type this one. I'm going to do Control V and paste. Change that to D. Now it says a vertical asymptote at x equals 5. Well, let's just put a 5 there. It says a horizontal asymptote at 0. I believe I've already got a horizontal asymptote of 0 just by putting that. In fact, I don't even need parentheses. Let's go back and get rid of them. And we'll verify that that's true. But as x gets really big, oops, I lost something here. What am I doing? There we go. I've got y equals 2 over x minus 5. Let's verify with the Desmos. So I'm going to go back and put in 2 over x minus 5. Okay. Well, it looks like I have a vertical asymptote at 5. These values are getting close to 5, but they'll never reach 5. Okay. Now, do we have a horizontal asymptote at 0? Well, yes, we do. You'll notice that it's approaching the x-axis on the right, and it's approaching the x-axis on the left. You can zoom out and see what's happening. If you zoom way out, you can see how this gets closer and closer to the x-axis. So it does have a horizontal asymptote at y is equal to 0. So D works. And by the way, those numerators are all 2's. You can make them whatever you want. They don't really have to be 2's. Just made up a number. I would be careful putting a variable because it may mess up one of your asymptotes in the denominator. All right, finally, a summary of transformations of functions. These transformations, by the way, are the same for pretty much all functions. But if you have a rational function of the form y is equal to a, and a being some constant, over x minus h, h being some constant, plus k, and k is a constant. That graph will have a similar graph to the parent function y is equal to 1 over x with a horizontal translation of h units. So it's going to go left or right depending on your value of h. A vertical translation of k units, it's going to go up or down depending on your value for k. And a dilation by factor a. So if you have a 2 on the top, the graph will be twice as steep. If you have like a fraction, 1/2, the graph will be compressed vertically, like half as tall. That number a is sometimes actually placed in front of the fraction, so it could be times that but in general, it's usually on the top of the fraction. The negative also can be placed with the a on the top, or it can be placed in the front, but it kind of works the same way. If a is negative, the graph's going to be reflected over the x-axis. The same is true for parabolas and other types of polynomial functions. If you have a negative a, it's going to reflect over the x-axis. And there will be a horizontal asymptote at y is equal to k. So whatever that y value is x gets really large, that fraction a over x minus h becomes closer and closer to 0, so you end up with y equals k. And the same can be said for the vertical asymptote. If your denominator is 0, x minus h is 0, then you'll have a vertical asymptote at x equals h. The other type of rational function that we see a lot is y equals a over x minus h squared. This graph has a similar shape to y equals 1 over x squared, and you'll remember that has two branches, but there's nothing underneath the x-axis. We saw one like this in the last lesson. All of the rest of that is the same. So horizontal translations, h units, vertical translations, k units, dilation factor a, and reflected over the x-axis when a is negative, and so forth. Now, for this exit ticket, you do have a form to fill out, but you will need your packet. So I want to show you what I mean. Click on the packet that you were given, and you will see these function graph cutouts, and they are labeled A through M. So A, B, C, D, E, F, G, H, and then one of these graphs, there's I, but you'll notice there's nothing on the card to the right of I. Then there's J, K, L, M. So one of the equations that you're going to get does not have a graph. And so when you get to that equation, just put that answer. That's the last answer choice. No graph is available for this function. But anyway, that is your exit ticket. So of course you could just type all the equations in your calculator and look at them, but I would encourage you to not do that. Instead, try to find the right graph, what you think is the right graph, and then before you turn in the assignment or submit the assignment, of course, you can go back and check each one with the graphing calculator. Submit that exit ticket and fill out your document that I gave you, and that is your assignment. So this is due, I believe I'm going to have this one due on Monday. Anyway, until we meet again, do your best, keep working hard, stay safe. If you have any questions, always, you can email me or leave a comment, and I will get back to you as soon as possible. Thank you.